Right. So what you are, yeah, delta is meaning change. Okay. So velocity is how fast the position is changing with time. Okay. So velocity means you have to include the direction.
Okay.
Speed means without the direction,
Okay.
just the magnitude.
Okay. So should I try solving it?
Uh, yeah, try.
Okay. So for which one? Oh, and just in general. Okay, never mind.
Okay. I think the B is obvious, right? Uh,
I think I got it. So basically, your velocity is basically saying that every second you're traveling 3 meters, 3 meters per second.
no, it can change, right? See, it need not be constant throughout.
Yeah.
Okay, first second to second second it can go slower. Second to third second it can faster. Okay, third second to fourth second it can move in the opposite direction. Okay,
Yeah.
so it can change, but within that interval we can calculate.
Mm-hmm.
Okay,
Okay. Because it's different every interval.
yeah. See, if it is not changing, then you can choose a big interval, saying that
Oh, okay.
this four
Yeah,
interval,
I see.
this is the speed. If it is changing every 1 second, then you break it up into smaller this thing.
Okay.
Okay, then you get more detail.
Okay.
Okay,
Yeah.
so
So
I
how do you
think
calculate?
so. The B part is trivial, right? Because uh, it is at rest from four
Yeah,
to
it's in
six
the
seconds.
same position.
It is at rest because the position is not changing.
Yeah.
Okay, what do you think is happening in the interval 6 to 12?
Mm-hmm.
6 to 12, time is increasing, but
Yeah.
distance is decreasing.
From 6 to
Okay,
12.
6 to 12,
Yeah.
time is increasing, but distance is
Mm-hmm.
decreasing, right? 12, 8, 4, 0. So it is moving in the opposite direction. It's moving towards
Yeah.
negative x. When you say 1D, you can say either positive x or minus negative x. Okay, so
Okay.
from 6 to 12, it is moving in the negative direction.
Okay.
Okay, that is negative x.
Okay.
How do you know means the position is decreasing?
How do you know? Because it's going from um 12 meters to 0.
Yeah, 12 to 8, 8 to 4, 4 to 0. So every step it is
Yeah.
decreasing.
Yeah.
See, since he has given every step, we can give smaller details. You don't have to look at the full thing as a whole. 6 to 8, something is
Mm-hmm.
information is there, so you can use that. 8 to 10, 10 to
Okay.
12. So 6 to 8 also it's moving the negative direction. 8 to 10 also it's moving in the
Yeah.
negative direction. 10 to 12 also it's moving the negative direction.
So from 6 to 12 seconds, you have a negative velocity.
Yes.
Okay.
Okay, the convention is velocity means direction has to be there. So right direction is
You
positive.
got cut off. Can you repeat it?
What?
The audio got cut off. Can you repeat what you said?
Okay. No, velocity means you have to give the direction. And in 1D problem, there are only two directions, either right or left.
Okay.
Okay. So right, you take it as positive. That's a convention. When you draw x-axis, you always put the right side as positive, right?
Yeah.
Now, so right is positive. So when it's moving on the positive side, you give the positive sign to the velocity or the speed. Speed is only the magnitude. So velocity, you have to put the plus sign. So from 6 to 2, the velocity is negative.
Yeah.
So total distance traveled.
Um, it has traveled.
See, total distance means the length of the path.
So 42 meters.
See, in this problem, uh, what is happening is from 0, it's moving towards the right up to 12,
Yeah.
and then it's coming back.
So 24 meters.
Yeah, 24 meters is the path length.
Okay.
Okay.
She has a key, so I'm gonna I can check it.
From the table
Like
you can it's obvious, right? Because from 0 to 6, okay, it's
yeah,
what? It's moving from 0 to 4 seconds, is moving from 0 to 12 meters.
the right direction.
Yeah, and 4 to 6 is staying there itself, and after 6 seconds it's turning back. So starting from 0 it's going to 12, and from 12 it's coming back to 0. So the
Okay.
distance traveled is 24. Right?
Yeah.
And displacement is the initial position, the final position, how much it has covered. Difference between the initial position and the final position. Okay. So that is how much here. This is the initial position, right?
Yeah.
And the final position is this one. So what is the distance between initial position and final position?
Yeah.
What is the distance between initial position and final position? This distance 0, right? On the x direction only. It's only 1D problem. So it's going here and coming back here. So initially it is at 0, finally it's also at 0. It is at 0.
Yeah.
So displacement from 0. So displacement from uh, total displacement of scalar after 12 seconds. So okay, the exact signal in between 0 and 12 seconds, the displacement is 0.
Yeah. Wait, can you explain it again?
The displacement between, see, whenever you say displacement, you should give the time interval. Okay.
Displacement of time?
Yeah. Displacement is initial position to final position, right? So what is the initial time? What is the final time?
0 and 0.
No. That is the initial time is t equal to 0. Final time is t equal to 12.
Yeah.
Okay. So when t equal to 0, what is the position? X equal to 0. At t equal to 12, what
It's
is the
0
position?
also.
X equal to 0. So it does not effectively traveled anywhere.
Okay.
Okay. So displacement is 0.
Yeah.
So what is the displacement between 0 and 4 seconds?
0 and 4 seconds.
Yeah.
So at 0 seconds, it's at 0 meters, and at 4 seconds, it's at 12. So it would be 12
Yeah. So
meters.
displacement is 12.
Okay.
Okay. So what is the displacement between 4 seconds and 6 seconds?
It would be 12.
No. Between 4 and 6.
They're both at 12 meters.
So what is the displacement?
Just 12 meters?
No, 0. See, it is the difference between initial position and final position. I'm saying from 4 to 12. From 4 to 6.
So the displacement from 8 to 10 would be 4 meters.
Minus 4. Displacement has got the sign.
What do you mean?
See, displacement means it can be either towards right or towards left. See, if you take from 6 to 8, the displacement is 4, right?
Mm-hmm.
But it is traveling in the minus direction.
So it's -4.
So it's minus 4. But between 2 and 4, it is plus 6.
Yeah, it's +6 because it's going 6 in a positive direction.
Yeah. So
Okay.
displacement is with the direction.
Okay, I think I've got it.
So displacement is vector, distance is a scalar. You know scalar vector? You know scalar vector?
No.
Scalar means, okay, then just forget the thing. With the sign is displacement.
Okay.
Without the sign is displacement. Sorry, distance.
Okay.
Distance is the path length, right? So it is
Yeah.
always positive. Displacement can be positive or negative depending on the direction, whether you're moving towards right or moving towards left. Okay.
Okay.
Similarly, the displacement between 10 and 12 is -4.
Yeah, because it starts at 10 and is at 4 meters and at 12 meters or 12 seconds, it's at 0.
Yeah,
And it's
right.
decreasing
So average speed, what is average speed?
from 0 to 12.
Yeah, what is the definition of average speed?
You take the time at that spot and then you add them together and divide it by the number of numbers that are there.
You have to get the definitions right. So average speed is
Yeah, it's just 0.
path length by time.
So distance by time.
Yeah, distance by time in whatever interval they have asked.
Oh, okay. So this would just be 0. The velocity or the speed would be 0 meters because you're
No,
at both moments.
no, speed is distance. No, distance is never 0. Distance is 24. Speed is
Oh,
distance
so
of
just
speed is
what?
how fast the distance is covered. Okay, distance is 24, right?
Yeah, but you're not just covering those specific intervals. You're covering the whole thing.
Yeah, because it's average. See, that's why they
Okay.
say average. Average means you have to take a finite interval.
So it travels 24 meters over 12 seconds.
Yes.
So your speed is 12 is 12.
No. 2.
Sorry, it's 2 meters per second.
Yeah, can you check the answer?
1 second. I don't know if she put it up yet, but she said she did.
Where is it? It's on the net.
I'm working on my iPad. I don't know if you knew that, but I'm doing it right now. I don't see it, so I think I'm just gonna email her and ask her for it, and I'll like text you.
No, you don't have answer key, is it?
She showed it to us, and she said she would post it on our like school thing,
Okay.
but I don't see it.
Okay, fine.
I'm gonna email her and ask her for it, and then I'll like let you know.
Okay. So average speed is distance by time.
Yeah, 2 meters per second.
So and velocity is displacement by time.
So okay. So then it would be okay. I'm gonna try solving it, and I'll let you know. Wouldn't it just be like 0 meters over 12 seconds?
Yes. So
So
0
then
by
what would
12. 0 by 12 is how much?
that 0?
Yes.
So you'd write 0 meters per second.
Yes.
Okay.
So if you say vehicle is traveling for this 12 seconds, so the fuel spent by the vehicle depends on the distance or displacement.
What?
Suppose a vehicle is moving, something is moving, right? From 0 to 12 seconds. Okay,
Okay.
let us assume it's a vehicle. Okay,
Okay.
the vehicle will spend some fuel, right?
Mm-hmm.
So the fuel spent by the vehicle depends on the distance or displacement.
The distance.
Yeah, because even if you go and come back to the same point, fuel will be spent. Okay,
Okay.
even though displacement is 0. Okay, so
Okay.
distance is not a useless thing because it also has some meaning.
Okay.
Okay, because the fuel spent depends on the distance.
So what exactly is displacement then?
Displacement is how effectively have you done anything. If you take the initial situation, the final situation, have you traveled or not? If you go somewhere and come back to the same point, effectively you have not traveled, no?
Yeah.
Okay, so that's like a useless thing.
And then your velocity is like
That's average velocity. Total displacement by total time
yeah.
is the average velocity.
Okay.
Okay, so whenever you take a finite time interval, it's average velocity. Suppose from
Okay.
t equal to 2 seconds to 4 seconds, the displacement is 6 meters. and time is 2 seconds, delta t. So the average velocity is 6 by 2.
Okay.
It's average between 2 seconds and 4 seconds.
Okay.
Average means you take a finite time interval. Within that time interval, you don't know how it is changing. So that's
Is your
it.
displacement just another way to say your position?
Which one?
Your displacement, isn't that just your position?
Yes.
Okay. So it's basically your position, your velocity is just your position over time.
How fast the push? Yeah. How fast the position is changing.
Okay. We usually use the word position, not displacement.
Position means it will not be moving. No. Displacement is the position is moving. Position is
Okay.
changing.
But your displacement is your final position to and your initial position, like the difference between the two.
Yeah, yeah.
Okay.
See, yes, suppose you are attending 5 tests, you can take an
Yeah.
average, right?
Mm-hmm.
So that is the average score, but its individual scores could be different.
Yeah.
So similarly, average velocity means you are taking finite time interval. Within the time interval, you don't know how it is changing.
Okay.
So shall we go to the third one?
Yeah.
Create xt graph using vt graph, assuming x naught equal to 0 meters number. So how from velocity, how will you get a position?
From your
See,
velocity.
velocity is given, right? So you have to find position.
So it's okay. So for the first like 8 seconds, your velocity is 10 seconds. So it would be 1 second v equals p over. Okay. So your position is going to be your velocity times your time.
Velocity is 10 meters per second, right?
Yeah.
At
So
this
that
point.
8
So
seconds. So it's at 80 meters. So at for the first 8 seconds, your position is 80.
no, initially it is 0. So at time t equal to 0. So
Yeah,
this
yeah,
so this is a point, right?
yeah.
This is one point. And after 2 seconds, the velocity is 10 meters. From 0 to 2, the velocity is 10 meters. So at the end of 2 seconds, how much distance you have traveled?
20.
20. So let this be 20. So this is another point, right?
Well, yeah, you have to do 20 has to be like at the first dash
Yeah,
because
yeah.
it's gonna reach 80.
Okay. So let this be 20.
Mm-hmm. Then 20, 40, 60, 80.
We can go to straight away to 8 seconds because from 0 to 8, the
I don't know
velocity,
if you can see it, but that's what I drew,
I can
right?
see. Okay, so at this point, 8 seconds have gone, right? So 8
Mm-hmm.
into 10 is 80.
Yeah,
So this is another point.
yeah.
So it will be like this then.
So then your next point would be 40 and then 60 and then 80.
And then it's minus 5, right? So in 1 second, it will drop down by half of it. It will come
Okay.
here.
So
Is that
you're so for the next 12 seconds,
See,
your velocity.
while going up, this velocity is 10. While coming down, the velocity is minus 5. So it will go down by half the thing. Okay. While going up in 2 seconds, it went up by one division, right? So while coming, it will go by half division.
What do you mean?
See, from 6 to 8 seconds,
Yeah,
it went from here to here, right?
yeah.
Okay. So the velocity increased by, the position increased by 20.
Okay.
So, but while coming down, it's coming at minus 5. So half
Yeah.
the, well,
So it has to be less steep.
so yeah, it should be half of the thing. From while going up, it is one division. So while coming, it will be half division.
Yeah.
And the second will be another half. So it will go up to 18. This is half division. So
So that's
up to this point it will go down. And after that it is
why
not.
would you put it at 20?
No, see, while going up every 2 seconds, it's going up by 20, right?
Yeah.
Okay, while coming down, the speed is half, no, it is 5.
Yeah.
So it will come down by half division.
Yeah.
Okay, so from 8 to 10, it is come down by half division. From 10 to 12, it's another half, so it will become 1. Again, from 12 to 14, it's half division. From 14 to 16, another half division. And then from 14 to 16 to 18, another half division. So it will stop here. And after that, it is same position. It is not changing.
Okay. Or, oh, okay, the way I see it is like you're at 80 meters, and so your total position that you calculate is -50. So you have to go from 80 to -50, so that's 30.
Yes.
Like 80 minus 50 is 30. Okay.
And from 18 to 20, the velocity is 0. So it remains the same position. And after it is going up by half division.
Okay. And then from there it's like 5. Your velocity is 5.
Yeah, plus 5.
Yeah, so it just goes up 1. Okay.
So they have made it simple while going in the positive direction is 10, while going in the negative is minus 5. So it is half of it. That's why its plotting is simple. Otherwise, it will become a little bit more complicated. Because while going up, for every 2 seconds, I'm crossing one division. So while coming down, for every 2 seconds, I will come down by half division.
Okay.
Because the speed is half. Okay, have they given you this relation x equal to ut plus half at square?
We only have x equals vt plus.
Okay, yeah, you can use that. X equal to vt, x equal to x naught plus vt. X at any time is the initial dis, displacement plus velocity into time. Right? X naught is 0 here.
No, that's not the one we have. Mine is x equals vt plus time.
No, x equal to vt.
Okay.
Okay, if there is some initial displacement, the vt should start from that. But here x naught is 0. Okay, so here x equal to vt then.
Okay.
Right, I think this is done then.
Yeah. We're on number 4 now.
The last one. Okay, two students moved in the hallway regarding the position as function of time. Construct with correct numbers the velocity versus. This is also this is the reverse of the previous one.
Okay. What about like we do it separately so we can see if I know how to do it.
Yeah.
Okay.
So velocity is how fast the position is changing, right? So from 0 to 1 second, it is covering how much position?
2 meters.
Yeah, 2 meters in. So velocity is 2, right?
Yeah. And then from 1 to 5 seconds, it's traveling 2 meters for 4 seconds.
Hold on. From 0 to 1, okay. After that, the velocity is traveling. Okay, the distance traveled. See, this is the distance traveled, right?
Yeah.
That is, sorry, this is the time. Distance traveled is this much. This distance traveled is 2 meters, and the time is 4 seconds, right?
Yeah.
So
So
the velocity is half, 2 by 4, half meter per second.
yeah.
So it will be here.
Yeah, that's what I drew.
Oh, no. I made a mistake. From 0 to 1 second, and then up to 5 seconds. No, I just have to extend it to 5. Is that right?
Yeah.
The way you're calculating is half is distance traveled by time. So you're taking the full distance from 1 second to 5 seconds, and the time from 1 second to 5 seconds is 4 seconds. The time interval.
Yeah.
Okay, because velocity is delta x by delta t.
Yes.
Okay, so the second one, again, distance traveled is this much. That is 4, and the time interval is 2. So how much
So
is
2 meters per second.
that? Is from up to 2 seconds, right? And after
Yeah.
that, here the distance traveled is how much?
It's traveled 2 seconds or 4 meters again. So -4.
No. Distance. See, the final position is -4. Okay, initial position is +4. So the total distance traveled is -8. This one is value is 8, but in the negative direction, right? So -8.
Okay.
Okay, so delta x is final x minus initial x. Final x is -4. Initial x is +4. So that is, and time is this much time. That is
Okay.
2 seconds, right? So
Yeah.
this is -8 by 2. So that is -4. Have you made a mistake here? No, the distance traveled is oh, sorry. What have I made? It is 0. No, I made a mistake here. Its final position is 0.
Yeah. And then you should get -2.
So it's -4, -2 from 2 to 4 seconds.
Yeah.
The positive thing, yeah, there is a mistake here also. The first part, this is not 4, right? This is just 2. The first part, the distance change in position is 2, in time 2, so it is +1. Okay, is that clear?
Yeah.
Okay, so one thing is uh, velocity is depend on the, see, velocity is delta x by delta t, right?
Mm-hmm.
And delta x by delta t is slope of
Line.
xt curve.
Yeah.
Okay, and you can see the first portion is less steep, the second portion is steeper, right?
Yeah.
It's falling faster. So that's why the second portion, the value is -2, or the value is 2, with the sign is -2. And the first part is moving up slow. It's a little bit less steep. So the value is +1.
Yeah. 1 meter per
Okay.
second.
For student 1, the first part is steeper.
Okay.
So that's
But
why,
then, wait, I have a quick question. Would it also be, would it be +2?
no,
Like,
uh,
um,
it's moving in the negative direction. No,
okay.
the student 1 is always moving the positive direction. But the student 2 has changed its direction. So delta x is final x minus initial x.
Okay.
Delta x, so final x is minus 4. Sorry. Again, mistakes. Anyway, it's a simple mistake. Final x is 0. Okay. Initial x is minus 4. Final x is 0. Initial x is plus 4. So 0 minus 4 is minus 4.
Yeah.
Okay. What is the next part of the question? Using the question as time, graph of student 2, write down the physics equation, including the units and describe the motion.
I wrote an equation.
X equal to u vt, right?
I said x equals in parentheses 1 second or 1 meter per second, finish parentheses t plus 2m.
So basically, the equation should relate v and x.
Yeah.
So v equal to x by t, or more precisely, you can write delta x by delta t.
Yeah.
In the interval 0 to 1, delta x is
Oh no, we're doing student 2. We're not doing student 1.
you can do for both, no?
No, it says student 2. I mean, you can do it for student 1, but
Okay, fine. No, but the equation is going to be same. Okay, but we have to, this relation is the same for whether student 1 or student 2. Here also the same thing only. V is delta x by delta t. First 2 seconds. Yeah, first 2 seconds, delta x is plus 2 and delta t is also 2. So that is why velocity is plus 1.
Okay.
Nothing more than that. Is it clear?
Yeah.
Okay, now this one. Suppose the motion of the student did not change at 2 seconds. Which student? Okay, both the students. Using the equation, write down. Just write down and show your work. Predict where the student will be after 12.5 seconds. How long will it take the student to reach the position that is 15 meters away from where he started? You understood the question?
Yeah.
See, in the one which is already given, at the end of 2 seconds or 1 second, what is the question? Is it after 2 seconds? No, so he's okay. Second student after 2 seconds. Okay. So after 2 seconds, the things are not going to change. So the first one after 2 seconds, he'll keep continuing the same way. Okay. The first student after 2 seconds, if he's going to continue the same, then he'll go like this.
Yeah.
Okay. So using these two graphs now, you have to find velocity or whatever you asked. Yeah. Where is the student? Position only. This first part is position in 12.5 seconds.
Oh, okay.
So velocity is delta x by delta t. Okay, and see velocity in this part. In this part, it's 2 meters by 4 seconds. It's half, right?
Yeah.
So it is half, and delta x is we have to find out, and delta t is 12.5 minus 1, so 11.5.
Hey, do you think you can give me permission to record?
I'm recording.
No, like I can record this meeting.
Yeah, you can record.
Yeah, but you have to give me permission.
Will it break? I'm recording here.
Oh, I can see it.
Hold on.
Okay.
How do I give the permission?
I'm not sure. I've never been a host for a Zoom meeting.
Okay, you can access YouTube, right?
Yeah.
Oh, so I'm recording, and after this thing, I'll put it on the YouTube and I'll send you the link.
Okay.
Okay, so you don't record. I'm recording. Okay,
Okay.
fine. So this relation is always valid. Velocity is delta x by delta t, and we are taking this interval because after this, before this interval, something else different is happening. From this point is a straight line.
Okay.
Okay, so from this point it's a single straight line, right? So in that I can use this relation v equal delta x by delta t, and in this point and in this part the velocity is 2 divided by 4,
So 1/2.
so half, and delta x is the thing we have to find out, and delta t is he's asking for 12.5. At this point the time is 1, so delta t is 11.5.
Okay.
Okay, so delta x is 11.5 by 2.
Okay. Wait, let me write this down.
So it will be 5.5 plus 0.25. So it will be 5.75. 5.75 from x equal to 1. Sorry, from x equal to 2.
Okay.
So, so the location at 12.5 seconds will be, that I put as suffix 12.5, will be the location at 1 second, that is 2. So 2 plus 5.75.
Wouldn't it be 2 times?
Why 2 times? See, delta x is 11.5 by 2, right?
Mm-hmm.
And 11.5 by 2 is 11 by 2, that is 5.5. And then 0.5 by 2 is 0.25, so it is 5.75. And 5.75 is the distance traveled in this time interval. And before this time interval, it has already traveled 2.
Okay.
So it is 2 plus 5.75. So it is 7.75 meters. That will be the position at 12.5 seconds.
Okay.
How long will it take? The same for the second student. So the second student, the velocity of the second student is same as the first part. So that is 1, right?
Yeah.
And delta x you have to find out, divided by, from here we have to, have a, okay, okay, here I have found out the delta x. I made a small mistake here. I have to find from this distance, no? From 2
Yeah.
seconds. So delta x from 2 seconds is that much. So delta x at the end of 2 seconds is,
For C, no, where the student will be after a total of 12.5 seconds of motion, the key says it'll be at 14.5 meters.
see that see at x equal to 2, this is the
No, the
position.
answer key says that it's
No,
gonna
hold
be.
on, hold on. Just first at x equal to 2, the position is 2.5, right?
Mhm.
So it will be 7 and then 8.25.
But then everything else we got right.
What is the answer key?
The answer is 14.5 meters.
For which student?
Student 2.
Student 1?
Student 2.
No, what about student 1?
There is nothing for student 1.
Okay, so what you have done is for student 1. So we can do for student 2. So for student 2, the velocity is 1. Okay, and delta x by delta t, that is uh, uh, question is what at the end of 12.5 seconds, right? So 12.5 minus 2, because we are starting from this position, 2. So 12.5 minus 2 is 10.5. Okay, so delta x is 10.5, and already I has covered a distance of 4, right? So x at 12.5 will be 14.5.
Yeah.
Is that the answer?
Yeah, it's 14.5.
So you got it right, because I'm choosing from this point.
Yeah.
I'm starting from here. So delta x from here, that will be, and delta t from here will be already 2 seconds have gone. So it will be 10.5.
Okay.
Okay, so from this, for this part, I will get delta x as 10.5, and the delta x of this part is 4.
Okay. So it's 14.5.
Yeah.
Both of these are with student 2, even the second question.
Okay.
How long will it take the student to reach a position?
Okay.
That is
How much time it will take for the student to reach 15 meters, right? So here x is given as 15.
yeah.
Uh, velocity is delta x by delta t. So velocity is 1, right, for the full part.
So when
Okay.
it is 15?
So here in this case, I can take this full thing itself. I don't have to take it from 2. I'll take this interval from 0 to the final part. Okay. So in that part, the velocity is 1, right? It's not changing. It's the same straight line.
Yeah.
So velocity is 1,
Times, like, in parentheses, it would be 15.
and delta x is given, right?
Yeah.
15 meter from where it has started. So 15 is the total this one.
Yeah. 15 seconds.
15 divided by delta t. This will give delta t as 15.
Yeah, it's just 15 seconds though, because it's time.
Yeah. I'm see from
But
this
can you
part. See, from this part to the whatever the 15th part is the same straight line, right?
Yeah.
So I can take the full interval as my region of interest. Okay. So in that full interval, the velocity is delta x by delta t, and velocity is the same thing. So it is 1, and delta x is the full delta x divided by the full delta t, and full delta x is 15, and delta t is from that I can get delta t as 15 seconds.
Okay. For D, I think it's because they have different velocities.
Yeah, because the slope is changing, right, at t 2 seconds.
Yeah.
Yeah, that is the reason. Okay, but this analysis, a single equation will do because it's one single straight line.
Okay.
But the original question, there is a change in velocity at t equal to 2 seconds. That's why you have to split it into 2 parts.
Okay. A third student is running, but instead of running at a constant speed, she continually speeds up. That
Okay.
is, she's going a little bit faster than the moment before. Will our general physics equation work to describe this motion? Explain why or why not. No, because it's changing.
Yeah, here velocity is like a straight line, right?
Yeah.
There the velocity will not be a straight line, horizontal line. It will be like this.
Yeah, no, because the velocity is going to be changing.
Yeah. Here the velocity is constant in intervals.
Yeah.
There the velocity will be something like this with a slope. Okay, they have not taught you like v equal to u plus at.
Our physics equation is or x equals vt plus x.
Yeah, so that means the speed is not changing.
Yeah.
Okay, when speed is changing, the equation will be a little bit more complicated. It will
Okay.
be x equal to ut plus half at square. U is the initial velocity.
Mm-hmm.
T square will come. So those things they are not at taught, right?
Yeah.
Okay. So the answer to this one is this cannot be used. Uh,
Because that's only
yeah.
describing one constant velocity, whereas this one is changing.
Yeah.
Okay.
Okay, you're done with this one.
Yeah.
So okay. So now what do you want to discuss? Maths or second physics?
Math.
Okay. Maths. Which one you want to? You can see
Um,
this list, right?
I sent you the notes and then I sent you actual homework.
See the one which you can see my screen, right?
Yeah.
So the one which you have sent are here.
Yeah.
Okay, and the name appears as function notation intro to transformations, and then DP IP02,
Mm-hmm.
IP3, IP4, IP4 2021 it says. So which one you want to discuss now?
IP2.
IP02. I think you sent it twice.
Oh, okay.
Okay, this is the one, right?
Yeah.
Okay, right following using intervals. Uh, okay, a less than or equal to -3, right?
Mm-hmm.
So it is from minus infinity to
What?
mm, so the first one, the interval will be minus infinity to
In
-3. So it will be like,
wow.
this is the notation you're using.
Yeah.
Okay. And on the left side is a curved bracket, right side is a square bracket.
Okay.
You know the reason?
No.
See, it's equal to, right?
Mm-hmm.
So equal to means -3 is included.
So if it's included, you do a square bracket.
Yeah.
But with infinity, you always do the parentheses.
Infinity is always a curved bracket because infinity is a,
Sure. It could be any number to
yeah,
infinity.
you cannot include infinity because its infinity is not exactly defined. It's a very large number. So infinity is always curved bracket. That you forget it. Okay.
Mhm.
If it is instead of less than or equal to -3, if it is just less than 3, -3, here will be curved bracket. Like for example, this one, the interval
Mhm.
will be 1, comma 3, curved on both the sides.
Yeah.
Because
Yeah.
it,
Why is it 1, 3? Why isn't it infinity?
no, here it is given, right? T is greater than 1,
Mm-hmm.
less than 3. So if you draw the t-axis, 1 will be here, 3 will be here. So this is this interval, right?
Mm-hmm.
So this interval is represented like this 1, comma 3. Starting from 1, you go up to 3, and 1 and 3 are not included.
Okay.
Okay. So can you tell for this one?
Number 4,
Yeah.
infinity, comma 0.
No. First is a lower number, 0.
Oh, it's always a lower number?
Yeah. Left to right, right?
Okay.
Left hand side is square bracket or curly curved bracket?
They're both curved, like normal.
No. Left side is included, no?
Yeah.
Is this correct?
Yes, because 0 is included.
Equal to sign is there, no?
Yeah.
What about second one?
I said infinity, comma 2. And
Minus
like,
infinity.
why is it minus?
Less than
Oh,
2, right?
less than 2.
So starting from 2, you have to go on the negative side.
Okay. And then I said I put a U.
Yeah.
2, and then these are regular brackets because 2 is not included. And then I put a U, and then I put infinity, comma 14, but 14 is in brackets because
14 comma infinity. Starting from 14, you have to go to right. Greater than 14, right?
why?
What does it say? Greater than 14.
Yeah.
So this is a square bracket.
Yeah.
14 is included.
Mm-hmm.
Infinity is always curved bracket.
Yeah.
So, and this means union.
Yeah.
So on the t-axis, say 2 is here, and minus infinity is here, and then 14 is here, and plus infinity is here. So the interval is this one.
Yeah.
Okay, and 14 is included. So you put a solid circle here, and minus 2 is not included. 2 is not included, so you put a hole here.
Okay.
If you want to represent by a figure, whenever some number is included, that you put by a filled circle.
Okay.
The number which is not included, you put a hole.
Okay.
That's an indication that that number is not included.
Okay.
Right. He has done. See, here there is a hole, no? So
Yeah,
that
it's
means minus 1
negative
and
infinity, comma -1, union infinity, comma 1.
1 comma infinity.
Okay.
Start from the left side is smaller number, no? First
Okay.
number is smaller number, or the one which is there on the left side.
Okay.
And curved bracket or square bracket?
All of these are curved.
Okay, and it's union, right?
Yeah.
What about 6?
6 is -5, comma 5, and then they're both in brackets.
What bracket?
The square brackets.
Because both are included.
Mm-hmm.
Okay, 7?
7 is negative infinity, comma 11, and 11 is in square brackets, whereas infinity is just regular.
Yeah, infinity is always regular. Right. Determine the domain and range of each function. So what is meant by domain?
Your x,
Yeah, and range?
your y values.
Yeah. So more precisely, what is the value of x for which the function can be defined? Okay.
Okay.
Certain functions cannot be defined for all values of x.
Okay.
You know square root of numbers.
Yeah.
What is square root of 4?
2,
Square root of -4?
2, -2.
-4.
There you can't square it.
So there the domain is positive x, positive numbers. There the value of x cannot be negative.
Okay.
So in general, the domain can be full real line, but certain functions, there will be some restriction. For example,
Okay.
square root of x, the domain is the positive values of x. It's 0 from 0 to plus infinity.
Yeah.
Okay. So for the 8th question, what is the domain?
Negative infinity, comma 6.
No. Negative infinity, comma plus infinity. Oh, okay. It's stopping here, no?
Yeah.
Okay,
So
fine.
6.
Yeah. And 6 is curved bracket.
Yeah. Because it's included too. It's an open circle.
It's not included.
Yeah.
Okay. Range?
-4 comma negative infinity.
No, there is no negative infinity. No, it's always positive. No, I mean -4. It's from -4. It's going up.
Okay. So it's just -4 comma infinity then.
Yeah. That's right. So the range will be whatever possible values of y. So the y can from it can go to this direction. It can go up anywhere, right? So it's starting
Mhm.
from -4 to plus infinity, and
Okay.
-4 is included. So here it
Okay.
is square bracket. Square bracket -4
Okay.
comma infinity.
Mhm.
Okay. This one 9.
Negative infinity comma infinity for
Yeah.
domain.
The
It's
full
traveling on both ends.
the full thing.
Yeah. And then my
Range.
range would be uh like in the square brackets -10 comma infinity.
Yes. This one.
-10 comma 8 and 8 would be in the square back brackets. And
Okay.
then -1 comma 8, but 8 would also be in the square brackets.
Yeah. -1 is not included.
Yeah.
Okay. Yeah, that's it. Okay. What next?
Um
This is IP2.
IP3. Well, I can do IP3 because we went over IP2. I think I'll be fine.
Okay. You try
And then,
if it is not done, we'll do tomorrow.
okay. Okay.
Okay. You want to do one more physics sheet or
So like because I'm doing online school, next week we have to go pick up textbooks and stuff. So I'm getting a physics textbook. So I think in that textbook there should be practice problems. So I'm gonna be able to get practice problems for velocity, displacement, time. So I'll send you them and then I'll do them. And if I have any questions, I'll let you know.
uh, so your school right now it's online or you're going to
Yeah, it's
classes?
all online. It's all online.
Okay.
But
Right.
I need to go pick things up.
You have to go and pick up things.
Yeah, like books. For my computer programming class, I'm getting a keyboard and a mouse.
Okay.
So I
And
have to go.
right. In addition to the books, they will give the soft copy also, right?
Um, well, they whatever worksheets we get in class is practice, but if I can go in and meet with my teacher and ask her for extra problems, which I think I'm gonna do.
Hmm.
So I'll keep you posted with that.
Okay. No,
I'll,
right now you have one more physics sheet or not?
not right now. She hasn't posted it yet.
Okay. So what about Akshay? He's going to college or
He starts next week on Monday, I think.
no? It's online or
Yeah, his is all online.
okay. What about his exams?
I'm not really sure. I don't think they take. I think it's different in college than it is in high school. I'm not really sure. I think you'd have to ask him.
Okay. So anything else?
No, I think I'm good for today.
Okay. Tomorrow you want to have a discussion or not?
I think so. Yeah. I'll
Okay.
do I'll do the math worksheets and I'll see if she posts the physics worksheet and then we can go over it tomorrow.
Okay. Fine. Okay. So
Okay.
send me a WhatsApp message then.
Yeah, I will, and I'll email you the PDFs.
Okay.
Okay.
Fine.
Thank
Send.
you.
Yeah. Bye.
Bye.